Hello class, Mr. Hanson again. Well, today we're going to talk about an application of exponents. That's logically next, I guess, and we're going to look at what's called scientific notation. So scientists, astronomers, people that use very, very large numbers, we're talking billions and trillions, or perhaps maybe biologists or chemists that use really small numbers when they look at atoms and protons, electrons, neutrons, all that stuff. They wanted a way to make life a little bit easier. Since we had all these rules on how to simplify exponents, they basically said, let's deal with the exponent rules. It's pretty simple, straightforward, and then we don't have to write all those digits all the time. So they came up with what's called scientific notation. Now, so let's say we have the number, I'll just start with an example, 46,000. Now, we both agree probably that 46,000 is not a huge number, but it's a good example to show you how the mechanics of scientific notation work. Excuse me, I had a refresh in my mouth with a little water there. So anyway, when you see a number that's traditionally written the way we're accustomed to, these are called customary numbers. Customary. So you can either write numbers in customary notation or what we're going to look at next is scientific notation. So the first thing, if you want to convert a number from customary to scientific, first off you want to identify where the decimal point is currently. And you're going to move this decimal point right or left until the number that is present is between 1 and 10. So what I mean by that is this. If I move the decimal point 1 to the left, I'm still at 4,600. If I move it one more time, I'm still at 460. If I move it one more time, it's still at 46, right? We want to get this thing so it's between 1 and 10. But if I move it one last time, I'm at 4.6, and I think you all agree that 4.6 is a number between 1 and 10. So what you do then is you say, okay, if we moved it to the left, count how many places to the left we went. 1, 2, 3, 4. Okay? Well, that's like saying taking 4.6 times 10 to the fourth power, right? Because this would be 4.6 times a 1 with 4 zeros behind it. And if we quickly did the multiplication, if we did traditional multiplication, we would get 0, 0, 0, 0, 6, 4. Count how many placeholders are behind the decimal. We have 1. And we're back to our customary number 46,000. So let me just kind of backtrack and summarize. So to write a number, we'll talk big numbers first, and then we'll talk little numbers next. Big numbers, I mean numbers that are bigger than 1. You want to move the decimal point, typically it'll be to the left, until you get a number between 1 and 10. In our example, it's 4.6. And you count how many places you moved. We moved 4 places. Oops, if I could spell places right. So this 4 then becomes your exponent on base 10. Okay, so scientific notation, we're going to use exponents with base 10. All right, let me do another example for you. Example 2. All right, let's try a number like, let's see, 5,876,000,000. 5,876,000,000. Well, as you can see, as we get bigger and bigger, it's kind of a pain to have to write that number out all the time. So the question is there a shorter way? And yes, we can use exponents. And then if we write it as exponents, then we can use our properties of exponents we've been looking at. So we got to move the decimal point. Remember, first locate where it is presently. Move this decimal until we get a number between 1 and 10. So I'm going to move it 1, 2, 3, 4, 5, 6. I'm not between 1 and 10 yet. I'm at 5,876. Gotta go one more. That's 587.6. 58.76, we're getting closer. Oh, I think the ship has landed at 5.876. So you write 5.876 times 10. And the rule is if you have to move it left, your exponent will be positive. So let's see how many places we moved. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be 5.876 times 10 to the 9th power. Okay? I'll write an example here. You try it now. Try to write 82,350. Try to write that in scientific notation. I'll give you a second. Please pause until you're done. Okay, so the answer would be 8.235. Okay, we moved it 1, 2, 3, 4 places, so it'd be 8.235 times 10 to the 4th power. Okay, so those are some examples using numbers greater than 1. Let's look at some decimals. Let's look at some small numbers. Let's look at something like 0.00041. Okay, that's a smaller number. Now we're going to do the same thing, except notice we're going to move to the right this time instead of to the left. So if we move to the right, okay, something changes. So let's do this one. So I have to move it 1, 2, 3, 4. I'm at 0.41. That's not between 1 and 10 yet. But if I move it one more spot, we're at 4.1. So this would be 4.1 times 10. Now we moved 1, 2, 3, 4, 5 places. However, if it's a small number and you move the decimal to the right, their exponent is negative. Okay? And the reason is because remember we did negative exponents the other day? You have 1 over, in this case, 10 to the 5th power, which is 4.1 times 1 over 1 with 5 zeros, 100,000. Okay, and this would be the same thing as 4.1 divided by 100,000. And if you do that, you're going to get 0.000, let me move this, sorry about that, 0.00041. Okay, you got to move it 5 spots, 1, 2, 3, 4, 5. Okay, so that's the thinking behind it, why it's negative. So if you see a negative exponent, you're dividing. All right, let's do one more. Let's say we have 0.0000578. And we want to write this in scientific notation. It's as simple as counting how many places we move, the decimal, until we get a number between 1 and 10. So there's 1, 2, 3, 4, 5. So this is 5.78 times 10, and since we move to the right, we make our exponent negative. All right, questions? Review the video if you have to. I'm going to just talk about a couple things about when we multiply and divide by scientific notation. So this is multiplying in scientific notation. So let's say, for example, we had 2 times 10 to the 8th times another number, 3 times 10 to the 3rd. So we have two numbers in scientific notation we want to multiply them together. Now, you could do this a couple ways. The long way would be changing these to customary numbers and then multiplying them out, but that would be defeating the purpose. So remember, I'm just going to show you just another example here before I do this. Remember we had like 3x to the 5th times 5x to the 6th. Remember what we did? We multiplied the coefficients and then added the exponents because the bases were the same, right? Class, if you think about this, this is the same thing. except we're just putting the times symbol in there. I mean, I could technically do this if I wanted to. I could say 3 times x, 5 times x to the 6th, and it would look similar to that. So essentially we have the same thing. So what you're going to do when you multiply scientific notation, you're going to multiply 2 times 3 together to get 6 times 10 to the, add the exponents, 11th. It's as simple as that. All right, let's do another example. Let's do 6 times 10 to the 3rd times 4 times 10 to the negative 2nd. All right, again, 6 times 4 is 24. Add the exponents. 3 plus negative 2 is 1. However, here's the deal. See this? We have to make sure that number is between 1 and 10. Otherwise, it's not technically in scientific notation. So what we do, if this number's bigger than 1, okay, presently, we're going to divide off. In other words, we're going to move the decimal place left 1 to make that 2.4. But we divided by 10 to do that, right? So I need to collect the pile. I took off a 10. So I'm keeping a pile of 10s over here, right? So you have to add that 10 to that pile of 10s we have over there. So you're dividing one off, dividing it by 10 to get it to 2.4. And you're extracting, think of it extracting, so you're going to pile the extra one over there. Okay? Makes sense? Alright, what if we have a situation, and let me do another example, where, trying to look for one here, let's say I had, well, let me do a division problem, and then you'll see what I'm talking about, because it'll be in this example. So let's look at division of scientific notation. Again, we know how to do stuff like this. 15 times 2 cubed divided by 5 times 2 to the first, right? We divide the coefficients and subtract exponents on the powers that have the same base. So this would be 3 times 2 squared, which would be essentially 12. Okay, so we're going to do the same concept for scientific notation. So let's say I have, trying to find one, here we go, 3 times 10 to the 9th power over 6 times 10 to the 5th. Okay, so we're going to do the same idea here. We're going to divide coefficients and subtract exponents. So 3 divided by 6 is 0.5, right? Times. Now 9 minus 5 is 4. Now here's what I wanted to bring up last time when I talked multiplication. Notice something again. We're in trouble because 0.5 is not between 1 and 10. Okay, so we need to multiply this by 10 to get to 5, right? In other words, we're going to move the decimal point one spot to the right, and if you have to move it to the right, we have to borrow a 10 from this pile over here to multiply it over here. So we got to take one off this pile. Okay, we got to take one off there. So basically the rule is if you have to move the decimal point to the right, you're subtracting a 10 off of the exponent. In the problem that we did over here, remember this number was 24 originally. If you move to the left, you got to add 1 to 10. So just be careful with that. Now that you only have to worry about that is if this number is not between 1 and 10 when you're done. Okay, let's do one more division problem real quick, and then we'll call our quits. All right, let's do something like 15 times 10 to the 4th divided by 3 times 10 to the 3rd. Okay, so I'm going to divide coefficients. I get 5. Well, that's good news. This is between 1 and 10, so we don't have to mess around with it. Subtract the exponents, 10 to the first. And there's your answer in scientific notation. All right, if you have questions, talk to me tomorrow. Thanks.